Good morning, students. Introduce myself. K. Janaki, Assistant Professor, Department of Mathematics, JJ College of Arts and Science, Pudukkottai. Today we have to discuss about the paper Probability and Statistics from first BSc Mathematics. Today my topic is some basic concepts of probability and Bayes theorem. What is probability? Probability is a simple here. Likely something is to happen. Whenever we are unsure about the outcome of an event, we can talk about the probability of certain outcomes, how likely they are. The outcome, this is the favorable outcomes. This is the simple concept of probability. We can see some basic terms of probability. First one is in probability, an experiment is any process that can be repeated in which the results are uncertainty. The probability has uncertainty event. Then second one, a simple event is any single outcome from a probability experiment. For example, tossing a coin, throwing a dice, etc. Third one is sample space. The list of all possible outcomes of the probability experiment is called sample space. For example, tossing a coin, the sample space is head and tail. Sample space is head and tail. Fourth one is event. Event means is any collection of outcomes from a probability experiment. Tossing a coin, for example, tossing a coin, sample space is head and tail. Event means only head once, so head is the event. Second one, probability. What is probability? The probability of an event denoted P of E is the likelihood of the event occurring. Then that is the probability of an event equal to P of event, P or P of E, which is equal to the number of ways it can happen divided by the number of possible outcomes. For example, when a coin is tossed, there are two possible outcomes. One is head and tails. You wanted to hit, so P of H equal to 1/2. Second one, the single dice are thrown. So there are 6 of possible outcomes. What is the sample space? Sample space is 1, 2, 3, 4, 5, 6. You wanted to probability of 1, which is equal to 1/6. Then again, this is the properties of probability. First one is the probability of any event E. Probability of E must be between the value of 0 and 1 inclusive. That is, 0 is less than P of E less than 1. Second one is if an event is impossible, the probability of event is 0. Third one is if an event is certainty event, then the probability of the event is 1. Fourth one is S equal to the set of all E1, E2, etc. En. Then probability of E1 plus probability of E2 plus etc. probability of En is 1. Next, mutually exclusive event or disjoint, that is cannot happen at the same time. Here, probability of them both occurring at the same time is 0. P of E and P of F or mutually exclusive event. Clearly the Venn diagram. Next, addition rule. Addition rule means for any two events are taken, E and F, that is P of E or F equal to P of E plus P of F minus P of E and F. P of E and F are mutually exclusive event, then P of E and F is 0. That is P of E or F equal to P of E plus P of F. It is clear to the Venn diagram. Next definition, complement of the event. Complement of an event is all the other outcomes. Together the event and its complement make all possible outcomes. That is P of E plus P of E dash equal to 1. This is the example for complement of the event. Now, according to the American Veterinary Medical Association, 31.6 percentage of American households own a dog. What is the probability that a randomly selected household does not own a dog? He is the own a dog. Okay, so P of E dash equal to 1 minus P, which is the formula. P of E equal to 31.6 percentage is given. So you have calculate P of E bar, which is equal to 1 minus 31.6 equal to 68.4 percentage. Next, we have discussed about independent event. Independent events are events such that the outcome one event does not affect the other outcome of the second one, and vice versa. For example, event A is rained on Tuesday. Event B is my chair is broken at work. This two events are not affected to the others. So this is a independent event. For a then next, mutually exclusive versus independent. If A and B are mutually exclusive, they cannot be independent because it make other event probability to be 0, it affecting other event probability. This is a mutually exclusive versus independent event. The next, this is the multiplication rule for independent event. The formula is P of A and B equal to P of A intersection B, which is equal to P of A star P of B. For example, suppose we roll on one die followed by another and wanted to find the probability of rolling get a 4 on first die and rolling an even number on the second die. So what is the probability? First, P of A is equal to rolling on 4. Okay, rolling on 4, and the second die is rolling on even number. Rolling on 4, A equal to set of all 4, second P of B equal to set of all even numbers. Single dice and sample space is 1, 2, 3, 4, 5, 6. So the even numbers are 2, 4, 6. A intersection B equal to 4. 4 is the common value of A and B. So P of A intersection B is equal to B is equal to 4A, which is equal to P of A intersection B is equal to 1 divided by 2. So two dice are thrown. So the sample space is 12, which is equal to 1 divided by 12. Next, we have to discuss about dependent event. What are the chances of getting a blue marble? The chances we are calculating the picture. 5 blue marbles are given. You will get the chances to which is 2 is first 2 in 5. But after taking one of the chances changes, even depends on what happened previous event and is called the dependent event. The next multiplication rule for dependent event. So the formula is P of A intersection B equal to P of A intersection B equal to P of A star P of B by A. P of B by A means event B given event A. In other words, event A has already happened. Now, what is the chance of the event B? Event B, that is P of B by A is also called the conditional probability of B given A. This is the conditional probability definition. What is the probability of drawing 2 blue marbles without replacement one by one? Event A is mentioned drawing blue marbles first. Event B is mentioned drawing blue marbles second. Then P of A equal to 2 by 5. Probability of drawing blue marbles first. B of B by A equal to 1 by 4. Event A has happened. What is the probability of event B? That is P of A intersection B equal to 1 divided by P of B by A equal to P of A intersection A and B divided by P of A. This is the condition for conditional probability. Then the next we have to discuss about the theorem, Bayes theorem. The Bayes theorem was developed and named for Thomas Bayes in the year 1702 to 1761. then it can be seen as way of understanding how the probability that a theory is true is affected by a new piece of evidence. Bayes theorem statement: if E1, E2, E2, E3, etc. En are mutually disjoint events with probability of Ei is not equal to 0, I value equal to 1, 2, etc. n, then for any arbitrary event A which is a subset of collection of union I equal to 1 to Ei such that P of A is greater than 0, we have P of Ei divided by A equal to P of Ei into P of A by Ei divided by P of A. Since a subset of U I equal to 1 to n Ei, we have you can take A equal to A intersection union of Ei, which is equal to intersection of A intersection Ei, u I equal to 1 to n A intersection Ei, by using distribution law. Since A intersection Ei subset of Ei, these are mutually disjoint events, then we have to using addition theorem of probability. So P of A equal to P the set of all union I equal to 1 to n A intersection Ei, which is equal to summation I equal to 1 addition by using addition theorem summation I equal to 1 to n P of A intersection I, you will get multiplication theorem of probability. By using multiplication theorem of probability, then it is we can write summation I equal to 1 to n P of Ei into P of A by Ei. Also we have P of A intersection Ei equal to P of A into P of Ei divided by A. From we get from 1 we will get P of Ei divided by A, which is equal to P of A intersection Ei divided by P of A. We apply the value of P of A, which is equal to P of Ei into P of A divided by Ei divided by summation I equal to 1 to n P of Ei into P of A divided by Ei, which is the Bayes theorem condition, hence the proof. Thank you.